Hi guys, happy Friday. I hope you're doing well. I know I'm feeling a lot better from where I was last week. But I figured I'd give you guys one more page of guided notes just to end the week. And hopefully, this will help you with your con assignments. And hopefully, it'll lead into some more work that we'll do next week regarding quadratic equations, quadratic functions, better known as parabolas. So we really only have two exercises to do on this page. Um, it would certainly benefit you to have a graphing calculator during this page because it's more or less working with tables that we can find on the graphing calculator. So if you don't have one at this point, we know that there's actually the app that works on the Chromebooks. Um, so I highly suggest that you access that. Again, if you need the link, email me. I can give that to you. But the graphing calculator will be very useful for this entire unit. Okay, so make that a priority to make sure that you have access to one. So on the first page, if we look back, we just kind of talked about what makes a quadratic function, the format of what the equation actually looks like. We identified kind of what the curve looks like. We said that they have minimums and maximums. We said that they have turning points. Okay, so this was just like that overview of what a quadratic function is. We said it always has a term raised to the second power. Okay. Now, if we go forward a page, we're given a quadratic function that says y is equal to x squared minus 2x minus 8. And part A says using a calculator, generate a table that'll help us graph. So here's what I did. I took my equation, I plugged it into my y1 on my graphing calculator. And then I hit second graph to get my table. And I'm going to just write my table of values for part A. Now, we're always given an x value and a y value. And believe me when I say we want to find the turning point of the graph where the minimum or maximum occurs. And that should generally be in about the middle of your table. All right, so I'm going to look for numbers to increase and then decrease. And I'm looking for, again, those output values to increase and then decrease, my y values. So if I look on my table, you guys can't see this because you're not looking at my calculator, but if you plug it in yourselves, you'll see values on the y-axis increase from 0 to -5 to -8, or rather, I'm sorry, decrease from 0 to -5 to -8 to -9, and then increase again, -8, -5, 0. Now, I know for a fact my turning point where my y values change direction occur when y is equal to -9 and x is equal to 1. Now I'm going to go two places in the negative x direction and two places in the positive x direction from that point. So if I do that, I have -1 and -5. I have 0, -8. I have 2, -8. And 3, -5. Notice the symmetry between my points. It goes from -5 on the y-axis back to -5 on the y-axis as I increase my x values. And I will most certainly identify this as my turning point. Now let me ask you, do you think it's a minimum or maximum? Well, being that my y values are decreasing and then they are increasing, I know that I have a minimum point, a low point on the graph, a smallest y value, if you will. Now I can graph. Now, granted, this is a 10 by 10 square, meaning it goes from positive 10 on the y-axis to negative 10 and positive 10 on the x-axis to negative 10. So I'm not going to have to label it, but I'll be able to find my points very easily. Now, I like to start with my turning point, and in this case, we know it's a minimum, and I want to plot that point 1, negative 9. Let's make that a little neater. 1, negative 9. So I'll go to 1 on the x-axis and negative 9 on the y-axis, and I'll plot my first point. And there is my minimum. Then I'll plot the rest. 0, negative 8. And notice symmetry tells me my other point that's symmetric to that will be right there. And it looks like it's going to be 2, negative 8, followed by negative 1, negative 5. Bless me. And 3, negative 5. And if I was to go up one more point, I might see that my next point is actually 4, 0. Okay, and 4, 0 happens to be right there. And I know symmetrically, negative 2, 0 will also be a point on the graph. Now, as I'm graphing this, I'm making my line curved. Notice it's not increasing at a constant rate, it's increasing at a changing rate. I stick an arrow on the end to let the reader know that my graph extends on and on forever. So there's my curved line here. And when you get up higher on the graph here, as I did, notice I didn't have any points to really connect, but it's not vital that you're 100% neat at that part in the graph. Those arrows extended just tell us that we know it goes on forever. We don't know if we're exactly right where we're at, but it does go on forever. And I know that one other point on my graph that I actually could have plotted was negative 3, 7 and 5, 7. So if you look, both of those points are on my graph. Okay. All right, so there's my parabola. There's my quadratic function. All right, now let's talk about some details of the graph. We know for a fact that my minimum occurs down there. And we can even list that point again, 1, negative 9, and list it as the minimum. We also can now look at letter B, which says to state the range of this function. Now recall, range asks us for the y values of the function. Where on the y-axis does the graph fall? Now granted, my minimum value will tell me my lowest point, which we know is negative 9. My maximum value is where it extends up to on the y-axis. Now granted, it doesn't actually stop in the y direction going positive. Notice the arrows on the end of the graph tells us it goes on forever. Therefore, infinity is my actual maximum range value. It doesn't end, it just keeps on going. And that is the range of the function. And it's listed in interval notation. Remember, close brackets include a point, parentheses do not include the point. You can include infinity, it's not an actual number. Now letter C says, over what domain interval is the function increasing? So now there's two things we have to talk about. Domain stands for my x values. Increasing asks us to talk about when it is rising, from left to right as we read, when is it going up, if you will? And up in the y direction I'm referring to. All right, so let's see. Well, my domain goes from there to there, and it looks like -3 to 5. However, if I was to continue graphing this point, realize it would go to infinity in the x direction, negative and positive. So my domain is technically from negative infinity to positive infinity. Now we want to know, when is it increasing over that domain? Well, if you look at your minimum value, and I'll highlight this in green, it is increasing from the minimum, and it continues all the way up the graph, on and on to infinity. So now, your minimum is at 1, -9. Now I said domain values were actually x values. So from that -1 all the way to infinity, the graph is increasing. Now realize the graph is flat at -1. It is our minimum. We do not include that point. And we do not include the point infinity because it is actually not a point. So my domain of the function increasing is from -1 all the way to infinity. Part D. Very important that we understand these concepts. Parabola's turning point. We want to state the coordinates. Turning point is also known as the vertex. And in this case, it's a minimum. All three of those terms are the exact same thing. And we know that that point is 1, -9, based on our graph. Now, I highlighted the minimum in red. Notice it falls at my lowest point of my graph, and it's always listed as a coordinate pair. Now, letter E says draw the axis of symmetry. All right, now, axis of symmetry, and I know I'm giving you a kind of a crash course in characteristics of a parabola, but the axis of symmetry is exactly what you would think it would be. It is a line, and it splits the graph symmetrically, or splits it in half. Both sides will match each other. The side on the left of the axis of symmetry matches the side on the right. Now, this axis of symmetry actually goes through that point known as our minimum, or our turning point. I'm going to draw it here in a, whoops, I got to change my color, in a blue line so that we kind of color coordinate all this. And the axis of symmetry is always vertical. It moves up and down. And notice it splits your graph in half and makes it symmetrical. Now the axis of symmetry, like I said, is always a vertical line. Therefore, the equation always starts with an x. X equals always represents vertical lines. Now you need to find your x coordinate. Well, we've already stated our minimum value to be 1, -9, where the x value is 1. So this straight line is represented by x is equal to 1. X is equal to 1 all along this axis of symmetry. And if you don't believe me, plot any point that you want. Plot 2 of them, plot 3 of them. You'll notice every point will start with 1 as its x value. 1, 5, 1, 8, 1, 0. All along your axis, x is equal to 1. Hence, the equation of that line is x equals 1. All right, now the last point I need to make, and probably the most crucial point, is letter F. It states, what are the x-intercepts of the function? These are also known as the function zeros. And why does it make sense? And you're going to see something right here that's very, very important. My x-intercepts are pretty simple to identify. They are where the graph crosses the x-axis. And notice, I'm drawing them in orange. They're right there. And they're represented by the points -2, 0, and +4, 0. Now, take your x values. We know that when x is equal to -2 and x is equal to 4, the graph crosses the x-axis. The output, or values of y, at these points is 0. Hence, calling them the zeros of the function. And it says, why does this make sense? Well, here's the connection between factoring polynomials and finding zeros of quadratic equations. If I was to rewrite my function as y is equal to x squared minus 2x minus 8, and I wanted to factor this polynomial, x squared minus 2x minus 8, I could find my zeros or use my zeros to help me factor the trinomial. Now, I know that x is equal to -2 and x is equal to 4 is a 0. If I reverse my signs and use a +2 and a -4, it will allow me to factor the trinomial and realize 2 times -4 is -8, and -4x plus 2x is -2x. I've successfully factored my trinomial. Now, if I take these factors and I set them equal to 0, as if I was finding my zeros, and solve, I'll subtract 2, and I get my x is equal to -2 again. And I'll add 4 and add 4, and I get x is equal to 4 again. Notice, both represent the zeros of my function. And there is the connection between factoring these polynomials or trinomials to the second degree and finding your zeros of the function. When you factor a trinomial, you're allowing yourself to actually identify the zeros algebraically. Okay, now, we can always see them graphically, just like we did on the graph. But eventually, we'll have to do this algebraically. That's that. Okay. All right, now, last thing for today. Exercise 4 gives us a quadratic function as a table. Now, I don't care about part B right now. I just want to make sure we can identify a turning point of the graph. Now, turning point, remember, always look at your y values. And in this case, we want to look for them to increase and then, decrease. So if it looks like it's increasing, and then decreasing, you'll be able to identify your turning point as 213. Now, how is this different from the ones that we've already done? Notice this was a U-shaped curve on our first page. We decreased and then we increased. The one we just did, same thing, U-shaped curve, we decrease and then we increase. Now we're increasing and decreasing. The graph in this case, and we haven't done any of these yet, let me redo that, will actually resemble something that looks like my upside down U, where the turning point is actually a maximum. And the function will be represented by a negative x squared plus something, 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 something. But it will be a negative x squared, which flips our graph upside down. Now, that was a lot. If you're looking at it, each step or each part in exercise 3 is a skill that we need to work on. Finding a table, finding your range, finding your domain, analyzing the turning point, identifying the axis of symmetry, factoring a quadratic to find zeros. Every one of those skills is necessary in this unit. Okay? We'll do more problems where we'll have to do the exact same process of graphing a quadratic and analyzing it. All right? This is a difficult page of the notes. Take your time as you copy them down. All right? Hope you guys enjoyed. See ya.